I would like to thank the organizers of this short-term course on cloud computing, particularly the institute that is Rajiv Gandhi National Institute of Youth Development and NIT Jalandhar, for giving me opportunity to talk with you all participants on this particular short-term course on role of and my topic for today's discussion is role of cloud in Internet of Things. So specifically, this particular short-term course is regarding the cloud computing, and my previous resource persons have actually talked about this cloud computing. So I've thought of that this particular topic of how we are going to integrate your cloud with the Internet of Things. So my today's discussion would be very generic one, and this would actually be emphasizing on the different aspects of cloud computing and what are the challenges over there and how we are going to mitigate those challenges. What is the architecture of the cloud computing? Though there might be some overlapping of contents, but ultimately the discussion would actually lead to integrating the cloud with the Internet of Things. So this is how we'll proceed with our today's discussion. The contents starts with the introduction, that is regarding the definition and the characteristics of the cloud. Particularly, we'll be talking about the definition and the characteristics of the cloud computing and what are the different definitions given in the literature. Then next comes is the why exactly we need the cloud computing and what are the benefits of cloud computing. Then we'll proceed with the cloud architecture, different service layers of the cloud computing, different cloud deployment models. Then after having this particular discussion on the cloud computing and different architecture and the service layers, we'll be talking about the IoT cloud that is integrating both the technologies and role of cloud in IoT and elements of IoT solutions. We'll proceed further with these topics and cloud reference architecture for the IoT. This particularly will be talking about the different case studies for this particular area of cloud Internet of Things, basically, and IoT cloud systems. And then I'll summarize my my lecture with certain conclusions. So as we can, the starting of this particular discussion is with the help of the definition of the cloud by NIST, basically National Institute of Standardization and Technologies, US. So according to them, the cloud computing is a model for enabling ubiquitous, convenient, on-demand network access to a shared pool of configurable computing resources. So here, with the help of the cloud computing model, what we are perceiving, we are trying to enable the ubiquitous, convenient, on-demand network access of shared pools. So what these shared pools or shared resources are, basically, it could be your networks, it could be servers, storage, applications, and services. So these are all the resources are there in the cloud computing environment. What we are perceiving is that we are perceiving an environment where we can utilize these resources on demand basis. And particularly we are talking about this networks, servers, storage, and application and services that can rapidly provisioned and released with the minimal management effort or service provider interactions. So what we want that there should be the minimal management effort from the or the service provider interaction would be there. So another perspective of this cloud computing definition is a collection of resources, that is combination of software and hardware, which is provided to the user on the pay-per-use basis over the internet. I mean, how much services you are going to get, that much ultimately you are going to pay for these services. So with the advent of this cloud computing environment, we are thinking of certain metering mechanism where we are, whatever services we are going to get, and ultimately for those services only we are going to pay. So this is the crux of this cloud computing. Cloud computing is the on-demand delivery of computing as a service, where you pay only for the services you used. So as lastly I've said that ultimately we are paying for only those services for which we are getting the facilities or services basically. And the hardware and software services are available to the general public, corporations, and business markets, etc. So ultimately, whosoever is going to get these services, either it would be public or some enterprise or any person in specific, so he or she can utilize the services which are available as a hardware or software. So next slide is talking about the particular scenario where essentially the internet connectivity, what we want in today's scenario is seamless connectivity, that is 24/7 connectivity, seamless connectivity of the internet, so that we are connected with the outside world and ultimately going to get the different resources with the help of this internet, going to get the different resources which are there as a part of the cloud. So way back when, I mean, this is almost very necessary commodities nowadays. As in previous time, the first example which we have quoted is drinking water distribution system. So we can create the analogy from there itself, where we used to, or the people used to fetch the water in their utensils from the water bodies. But with the help of water distribution network, ultimately we end up with the seamless delivery of the water with the help of water distribution network. Likewise, in earlier times, the people used to have the kerosene lamp or the candles in order to lit up their houses to do their daily tasks. So with the help of the electricity distribution system, whether you are talking about some remote villages, or you are talking about some towns or cities or metros for that matter, ultimately we have ended up with the seamless electricity delivery system with the help of electricity distributed system. Now, in today's scenario, and particularly in 21st century, what we are perceiving is that everybody wants to have the internet connectivity, the different resources which are there in terms of the computational facility, in terms of the storage, in terms of any other areas, say for instance servers, the servers, the storage, or any other task we are requiring with the help of the clouding. So conventional computing was like your standalone systems or desktop systems which are not connected to the outside world. But with the advent of the internet, we are perceiving that 24/7 we are connected with the help of the internet, and ultimately all the resources which we require in order to complete our tasks that are available to us. So with the help of this cloud computing environment, and nowadays when we are talking about the internet of things and all, we have these facilities which are available to us. So we can categorize these cloud computing services in different types. That is, on demand self service is one of the on demand self service. Why we are calling it as on demand self service? Basically, cloud computing resources can be provisions without human interaction from the service provider. So without the human interaction, so what we want is the least human intervention in between, in order to get the services which are which are being provided with the help of the cloud computing, we want the least human intervention in that. So this can be a storage space. What kind of services we can think of getting with the help of the cloud computing? This can be the storage space, virtual machine instances, database instances, etc. And next is the broad network access. So cloud services are available over the network, ideally high broadband communication links such as internet, or in case of private clouds, it could be a local area network. So broadband communication link is basically required, or the broadband link internet connection means the internet what we are going to have with the help of that. And in case of private clouds, it could be the local area network. Now, third aspect of this discussion is the multi-tenancy and resource pooling. By the term multi-tenancy, you must be clear about this particular thing, that we want to have a kind of scenario where we are talking about a cloud computing resources are designed to support a multi-tenant model. Multi-tenancy allows the multiple customers to share the same application or the same physical infrastructure while retaining the privacy and security over their information. So obviously, when there are multiple stakeholders, for example, take any application, any application of Internet of Things or the cloud services which are going to be provided by the service providers. So ultimately, we are very much concerned about the privacy and security of our information, because the data which is private to us, which is very personal to me, I do not want to share it with anybody else. So privacy and security are whenever we are talking about multi-tenancy, I mean multiple people are there, multiple users are there who are going to share this particular infrastructure or this particular technologies. So definitely the privacy and security would definitely be a concern. And definitely when the other part, resource pooling, obviously we are talking about pooling of the resources so that we can optimize our solutions. I mean, not everybody wants to have or wants to buy the infrastructure which is actually required by me, the computational resources or the storage space or something like that. But at the same time, when we are talking about the multi-tenancy or the resource pooling of the resource pooling is being done, then definitely the major area of concern is the privacy and security. Next comes is the rapid elasticity and scalability. As far as rapid elasticity and scalability is concerned, cloud computing definitely is going to provide with this particular ability. And with the help of what it does is it quickly provisions the resources in the cloud as manufacturing organization need them, and then to remove them when they don't need them. So this is on the fly. This is called the rapid elasticity and scalability. Whenever a user is going to require certain services from the cloud, it is available to them, and after using them, these services are going to be removed from and these services are going to be removed. I mean, ultimately, these services are available on the fly to the user. This is the ultimate meaning of rapid elasticity and scalability is concerned. So I hope this, the last in this series is the measured services. Obviously, we are talking about metering and all. As in one of the last slide, we have seen the water distribution system or the refined electricity distribution system. So definitely over here, when the user are going to utilize the different resources which are available to them. So obviously, and we have also mentioned a notable point over there that the services which are required or which are being utilized by a user, for that only they are going to pay. So measured services or metering kind of thing should also be there, as we have in case of water distribution system and electrical system. So cloud computing resources usage is metered, and manufacturing organization pay accordingly for what they have used. So resource utilization can be optimized by leveraging charge per use capabilities. So these are some of the things which we want to deliberate upon, and we want to highlight. These are the characteristics of the cloud computing, whether it is measured services, whether it is rapid elasticity and scalability, or the previous one, multi-tenancy or the resource pooling, broad network access, on-demand self-services. So these are some of the things which are there as a part of the cloud computing. And with I hope that with these 5 points, I'm able to give you an idea about the characteristics, or what are the things which are available in case of cloud computing. Now, as a part as a that next question which arises over here is, why cloud computing, or what is the need of cloud computing as such? So these are the facts which have been written in the slide itself, that it is the forecast that between 50 to 60 billion devices will be added to the internet by 2020. So obviously this is a huge number, and obviously by this particular number we can think of that a particular user, when we are talking about a single user, will be having the multiple devices or gadgets which are with him or her for the usage. And ultimately, when we are talking about this huge number of 50 to 60 billion devices, so definitely over here the contribution is also from the Internet of Things, where we are talking about certain things which will be having the internet connectivity, and ultimately data is being produced with these devices. So ultimately, why cloud computing? This single point is emphasizing on this particular this particular technology, that why we want to have the cloud computing in place. This is already in place. We are using this technology from large so many years, but ultimately this has been matured, and with the upcoming fields like Internet of Things, and particularly whether we talk about Internet of healthcare things, or Internet of medical things, like etc. This is one of the example: Internet of medical things or Internet of healthcare things. We can think of the scenarios where we have multiple devices which are being attached to the internet. Ultimately, large number of data is going to be produced. So second point is regarding the 43 trillion gigabytes of data will be generated and will need to be processed in the cloud data centers. So this is a huge data. As I've already told you, that huge data is going to be is going to be catered by these data centers basically. And increasing the capacity means buying more servers or infrastructure. When we are talking about that by 2025, why this particular point comes into the picture? When we are talking about that by 2025, we are going to have this much number of devices which are going to be connected to the internet. So obviously we'll have to expand the capacity of our servers, our infrastructure, and this may actually require some time. And the why exactly is the what is the need of cloud computing? All these points are actually emphasizing on the need of the cloud computing. Basically, with the help of cloud computing, we are going to reduce the cost. We are going to increase the scalability. Remote access. We are going to provide the remote access to the services which are going to be provided by the cloud computing. Disaster relief is one of the area which where cloud computing can play a major role. Ease of implementation is there. When we are talking about that, minimal intervention from the service provider should be there. So that is your ease of implementation. Skilled vendors are there. As I've told you, that cloud computing is one of the area which has been now matured. Now, in with integrating these technologies with the latest technologies or the upcoming technologies, we can take the advantage of these technologies. Response time is low, easy to customize, virtual provisioning is there, and fully automated storage tiering is there. Fully automated storage tiering is there. So what kind of services this cloud is providing us? This is all. These are all the advantages or benefits we are getting out of the cloud computing environment. So again, the benefits of cloud computing are very much clear from this particular discussion, and we have seen that cost saving is there. On the mobility, on the go, you are having this particular facilities which is available to us. We are going to have backups, we are going to have resource pooling, we are going to have infrastructure as a service and uptime, and work collaboration. These are all benefits of the cloud services. So I hope by this time that I am able to give you the basically the foundation of this particular cloud computing environment and why we are using it. So these are all benefits, pay per use, and these are all accessibility from anywhere, increased scalability, dynamic provisioning. These are all benefits of the cloud computing. So history of the cloud computing, I don't want to indulge in very much into the history of the cloud computing, but definitely we have started from this particular evolution of cloud computing. This particular slide is talking about the mainframe area where a user is connected to the mainframe. So what exactly is the mainframe kind of scenario? In mainframe, we have some centralized machine, and this centralized machine is being connected to the different terminals, different users basically, and those terminals are basically the dumb terminals. And after that, a scenario comes on the right hand side, where I'm just pointing it down with the help of the personal computers. We are going to utilize the personal computers, and that is a very crazy word days. And then we have made a scenario. I mean, with the help of the network, where are different kind of PCs, different laptops, different gadgets are being attached to the network. And after that, we have everything connected to the internet. So this is overall is known as the computing paradigm shift, right from your mainframe computers up till your internet and grid computing, and then the cloud computing. And then there is a question mark. That this question mark is particularly very much giving you an idea that if this cloud computing area or the technology is matured enough, then how we are going to tap this technology with the upcoming technologies like Internet of Things and all. So obviously there lies something in between after after cloud computing also, and that is we are emphasizing today. Peer-to-peer approach. This peer-to-peer approach is a decentralized approach, and it encompasses no principal server as we have in case of mainframes. It is designed in which every computer has equal responsibilities and facilities. So what we are perceiving in this peer-to-peer kind of approach is that each and every machine does have equal capabilities, equal responsibilities, and equal facilities available to them. So this is a peer-to-peer approach, what we usually call. Then in this particular slide, what we are showing is that the distributed computing scenario. In distributed computing scenario, we have different users which are giving the request for different services like PaaS, that is platform as a service, software as a service, infrastructure as a service, or any other in between any other classification. So all these users are giving the request for these facilities, and ultimately a user is going to give the request to the database server. So with the distributed computing environment, what we are trying to mitigate a kind of problem where we don't want one of the servers to be over busy and rest of the services are while free. So what we are going to do in distributed computing is that we redirect the traffic to other servers, so that they can get the benefit of the freely available services, and so that they can get the access to the desired request very easily and very quickly. So this will give you an idea of distributed computing environment, what we have actually utilized. Then the concept of virtual machines like VMware, using virtualization softwares like VMware, it is possible to execute one or more operating systems simultaneously in an isolated environment. So obviously, whenever we are talking about a virtual VMware kind of software, so definitely you can think of the advantages associated with that. We don't, within the single environment, we are talking about executing one or more operating systems simultaneously. So this kind of scenario, this kind of facilities are being given by the virtual machines, which are permitting us multiple distinct computing environment to reside in one of the physical environment. So these are all advantages of this this cloud computing. The following list briefly explains the evolution of the cloud computing, right from your grid computing. As you already know, basically the your background is from the computer science, so you already know, you might already know that grid computing is regarding solving the large problem with the parallel computing, and utility computing is offering computing resources as a metered services. Software as a service, this is software as a service, network based subscription to the application. So nowadays we are talking about the subscription and network based subscription and all. So this is all there. And cloud computing is anytime anywhere access to the IT resources delivered dynamically as a service. So over here we are briefly explaining the evolution, how this has evolved up to the computing cloud computing level. So this is something news on cloud computing. I don't want to go into that, but definitely I would wish to discuss this cloud architecture which is available to us, where this when we are talking about the cloud computing, at the lowest level we have infrastructure in terms of computing facilities, in terms of the storage, or in terms of the network facilities. These are all talking about the infrastructure. And when we are talking about the platforms, we have some object storage, we have some identity verification, we have from some runtime things, queue and databases associated as a platform. On the top of the infrastructure, we have platforms, and ultimately at the top layer we have different kind of applications which are there as a part of the cloud computing. This is the user interface, basically for what purpose they are going to take the advantage of the cloud computing, whether it is something regarding monitoring purpose, for content verification purpose, for collaboration purpose, for communication purpose, or for financial analysis, etc. So these are all applications. These are not definitely limited to these applications only, but definitely the application area of this cloud computing or the cloud architecture particularly is very vast, though we have tried to incorporate few of the things over here with the help of monitoring, content verification, collaboration, communication, and the financial analysis, etc. So this is the same one and the same thing, that this cloud computing architecture, how the different devices are connected over the cloud, and ultimately taking the advantage of the services which are being provided with the help of the cloud computing environment. I hope up till now you're very clear about the things. And as far as this cloud computing architecture, this architecture is based upon the different. I mean, this could be done on different criterias. One of the criterias could be on the basis of resource provisioning. Another could be on the basis of resource scheduling, or how we are going to allocate the resources to a particular task. Then another point of discussion could be on the basis of load balancing. Load balancing is, I hope that in last lecture you have talked about the load balancing and all. So my particular lecture is giving you the generic ideas of all these things, not very detail of any particular aspect, but definitely we are seeing the overall things in cloud computing. On the what could be the another point of discussion could be your on the basis of storage management, on the basis of hypervisor installed, on the basis of the migration, on the basis of service relocation, and on the basis of failure detection and the recovery. So these are all the criterias for the cloud computing, on the basis of what we can do the comparisons for different services which are being allocated for the cloud computing. So definitely there are some similarities and some differences in the grid and cloud computing. So definitely, as far as similarities are concerned, we are not very much concerned about the similarities of the grid computing with the cloud computing, but definitely we'll be stressing upon the differences. What are the different differences that the cloud computing offers? Software as a service application, where grid computing is used when processing authority of service or an application is distributed across multiple systems. So obviously in grid, we are distributing whole of the tasks to the different users, whereas in cloud computing, we offer software as a service applications. So with the cloud computing, the corporation acquires the feasibility and expense savings, whereas in grid computing, the corporation acquires suppleness and authority. So these are the differences of the cloud computing with the grid computing. So definitely cloud computing does have an edge over the grid computing. So features, I mean, these are some overlapping things what we have seen as a characteristics, as an benefits of the cloud computing. The features of cloud computing says that it is an on-demand self-service. Broad network access is there, resource pooling is there, a rapid elasticity is there, measured service is there, multiple persistence is there, dynamic computing infrastructure is there, elasticity and scalability is there, IT service centric approach is there, and standardized interfacing is there. So these are some of the points, these are some of the features of the cloud computing. If we just want to what we can say, want to summarize the things about the features of the cloud computing, these are giving you the summary of the features of the cloud computing, whether you talk about in terms of the benefits or the characteristics. These are some overlapping things. So next comes is your cloud service layers, where we'll be talking about the software as a service, platform as a service, infrastructure as a service. So different kind of applications. What kind of applications are there as a software as a service, like Google Apps, NetSuite, Lotus, Yahoo Mail, Hotmail? These are all are as a services, software as a services. Platform as a services, we have utilities like VMware, Cloud Foundry, Google App Engine. These are all there as a platform as a services. And lastly, we have infrastructure as a services, for which we have VMware again, Amazon EC2, Rackspace, Google Cloud Storage. So these are all the utilities which are available for us as a cloud services layers, in terms of your software as a services, platform as a services, and infrastructure as a services. So these are all services. Software as a services, when we are talking about this particular scenario where we want to have software as a service, the capability provided to the consumer is to use the provider's application running on a cloud infrastructure. So whatever application is, this particular application is running on a cloud, and ultimately the consumer or the user want to have a instance of this particular software onto their systems, whether it is desktop, laptop, palm top, on their mobile, etc. So this is being said as the software as a service. So example of top SaaS companies are Microsoft Office, Microsoft in terms of Office 365, Google Apps, Salesforce. These are all top service as a software as a service companies. So when we talk about the platform as a service, this actually platform as a service is offered the development environment to the application developers. So you can easily distinguish between what exactly are the services. Software as a services, what we have said in that in software as a service, we were talking about providing the software or the instances of the software onto our personal devices. Whereas in case of platform as a service, the cloud is going to give you the development environment to the application to develop the application softwares, etc. So this is the main point about the top this platform as a service. And the top PaaS providers, platform as a service providers, are AWS Lambda, Morpheus, Salesforce platform, etc. These are all the providers which are providing us the platforms in order to develop the application software, etc. So next comes is the infrastructure as a service. When we are talking about infrastructure as a service is the delivery of technology infrastructure as an on-demand scalable service, and usually built based on the usage, and usually multi-tenant virtualized environment, and can be coupled with managed services of operating system and application support. So multi-tenancy and regarding the metering of these services are concerned, we have discussed it in very detail. So over there, are in our mind, infrastructure is the only thing which is we were talking about that at that time, where we want to fetch the infrastructure on demand, basically, and on scalable basis. And best infrastructure as a service providers are Amazon Web Services, Microsoft Azure, Google Cloud Platform, IBM Cloud. These are all there as a infrastructure as a service. So cloud database is another aspect. A cloud database is a type of database services that is built, deployed, and delivered throughout the cloud platform. And cloud database typically run on the cloud computing platform. So basically, till now, what we have talked about software as a service is one of the thing. Another is platform as a service, and third one is the infrastructure as a service. Now, this database as a service is another classification. What we can deployment, as far as deployment models are concerned, there are two primary ways to run a database in the cloud. One of the ways with the help of the virtual machine, basically, and another one is the database when we are doing the database as a service. So when we are talking about a database as a service, with this model, owners don't have to install and maintain the database themselves. So this is true for everything, whether we talk about the services, whether we talk about the platform, whether we talk about the infrastructure. This is also true for the database, that owners don't have to install anything and maintain the database themselves, but instead the providers provider takes the responsibility of installing and maintaining the database, while the owner gets the gets appropriately charged. So accordingly, the user who are using the services are accordingly going to be charged for the services it has fetched or it has utilized. So this is about the database as a services. In case of data models, I don't want to go into the details of the database model, but I've given you some basics about the database as a service. So this is about this only, database as a service. Uh, okay. Apart from the database as a service, we have something which is called as the communication as a service. Have you heard about the communication as a services earlier also? I'm just posing a question to the participants. Have you heard about the communication as a service? Okay.
No, sir.
Leave it. Okay, leave it. Then communication as a service is a method of delivering communication services in a method akin the software as a service delivery, where we are talking about the communication services in terms of which includes VoIP, voice over IP, instant messaging, message routing, call recording, and video conferencing, etc. So whatever are the means in during this pandemic times. For example, this particular meeting is going on Cisco WebEx. So definitely this is a part of communication as a service. So everybody, every company, or whether we talk about the Skype, or whether we talk about WebEx, or whether we talk about the Microsoft Team, these are, or Google Meet, these are all service providers for communication as a services. So all these companies are providing us these facilities like voice over IP, instant messaging, message routing, call recording, and video conferencing, etc. So in today's time, this particular scenario where we are actually utilizing these technologies very efficiently, and through these technologies, because these technologies are available to us. So that's why distance doesn't matter nowadays. We are taking the online classes, we are taking the online lectures, we are doing all these things only with the help of if these kind of technologies or this kind of services are available to us. That's why today I'm emphasizing on this particular aspect of cloud computing as communication, which is communication as a service. So many people are familiar with the consumer cash solutions like Skype, FaceTime, and instant messaging tools like Facebook Messenger. However, mainstream adoption of the communication over the public internet has been relatively slow. But nowadays we cannot say that we are ultimately using it, and it is very much being utilized properly. And nowadays we don't have any hesitation in saying that these are the technologies which are new normal in times to come. So it's worth noting here that VoIP isn't necessary as a public internet solution. It could just be easily to be used over the dedicated circuits like a LAN or WAN. So this is about the communication as a service. What are the advantages of communication as a service? Some of the advantages I've already quoted. I've already explained that these are the advantages, and particularly during this pandemic time when we are staying and this. So communication as but formally, if we say that communication as a service offer the potential to manage multiple services, whether it is voice, video, data, or multiple devices, whether it is landline, telephone, mobile, smartphone, PCs, in a controlled environment, obviously. And if it offers the greatest potential for small businesses and enabling the utilization of UIP, VPN, uh, uh, virtual private networks, PBX, and unified communication without the need to invest in upfront cost or the hardware or the need to employ the skilled professional required to manage the mainstream system. So ultimately, this is all advantage. I mean, you all are using the same platform or which I'm using for delivering my lectures. You are basically utilizing that platform in order to attend this particular short-term course. So basically, there is very least intervention from the service providers. The only thing what we require is the internet, and ultimately, with the help of these things, human intervention, human interaction is the least, but ultimately these are the technologies what we are going to utilize for times to come. So next point of discussion comes as the region and availability zones. Availability zones is a collection of data centers basically. Availability zones is the collection of data centers. When we are talking about creating the data centers, then definitely this has to be very judiciously done decision that all the data centers should be located in same building or same city, and a region consists of multiple availability zones. Failures of one availability zone does not impact the other availability zones. So definitely if we do have a kind of scenario where we have different data centers and we are perceiving the idea of fetching a particular information from a data center which is locally available. I mean locally in terms of which is nearest to me, but ultimately in times of failure, this should not hamper uh, uh, the availability of the information or availability of services to the users. If something goes down, then definitely some other data center or some other service providing agency should take over and ultimately giving the services to the users. Then question arises is that how to decide that which region or availability zone would be the best for services or business purpose. This is the question which ultimately you and me people have to answer with the certain solutions, with the design of the data center in such a way that availability is at the foremost front basically. And over here we'll be talking about the latency cost, keeping in obviously these decisions, whatever decisions we are going to take as a data center designer or something like that, we'll have to keep all these factors, latency, cost, energy, service availability, into the consideration. So this is regarding the region and availability zones. Now, next is regarding the cloud deployment models. I mean, what are the different models for deployment of the cloud? One is the public cloud, another is private cloud, third is the hybrid cloud, and next one is the community cloud. So public cloud, we all are using the public clouds as such. Public cloud services are available for general public over the internet. Amazon Elastic Computing Cloud, Google App Engine, Windows Azure service platforms, etc. are the example of the public cloud. Those offered the services either pay per use basis, or there are also some of these services are also free. So this is regarding the public cloud. When we are specifically talking about the private cloud, so definitely we are talking about an enterprise cloud or a cloud which is specifically been designed or been fetched by some corporation or enterprise, etc. So this is a private cloud environment and is often the first step for the corporation prior to adopting the public cloud initiative. So as the name suggests, next one is the hybrid cloud. This is a mix of public and private. Some of the computing resources are available on site and some are available off site, that is on public domain, that is on public cloud basically. So this is the hybrid cloud. And community cloud is formed when several organizations with similar requirement share the common infrastructure. So this is how we can these are the different models for the cloud deployment. So this is nothing but the same discussion about the public cloud, private cloud, hybrid cloud, and community cloud, etc. So public cloud, as some of the example we have quoted, private clouds also, hybrid cloud. This cloud is a combination of private and public cloud, which is mutually dependent upon each other. So mutually dependent upon each other, that some of the resources, some of the computing resources are available locally or on site, and it may also take the advantage of the public cloud or the resources available at the public cloud. So this is the public cloud, and community cloud falls between the public and private cloud category. And the drawback related to the community cloud is that having the cost higher than the public cloud. So this is something related with the community clouds. As far as list of cloud service providers are concerned, we have Amazon Web Service, Microsoft Azure, Google Cloud Platform, IBM Cloud Services, Adobe Creative Cloud, VMware, Xspace, Red Hat. These are all service list of cloud service providers. And the major cloud computing vendors are these are all vendors for the cloud computing environment, whether it is Amazon, Google, HP, IBM, Microsoft, and all. These are all the vendors, the cloud computing vendors, basically. Amazon Web Services, Microsoft Azure, Google Cloud Platform. I mean, again, Google more onto these services which are available as an Amazon Web Service, what it actually constitutes of, Microsoft Azure, Google Cloud Platform, etc. These are all there as a part of the cloud computing. So for more reading, basically this is going to take much more time in order to discuss these because these are the full-fledged topics which require some discussions, but giving you an idea about these platforms which are available. Now, as far as limitations of cloud computing is concerned, so limitations are also there, that availability in terms of availability of services. Obviously, this is going to, this is a endless kind of point where as far as availability of services are concerned, today we have 100 type of services which are available on the cloud. But definitely the users urge for more, and definitely they'll have to take advantage by providing the availability of more services which can be provided on the cloud computing environment. Then internet connections, this is one of the limitations. If the internet connectivity is an issue, then definitely providing the seamless cloud computing environment or providing the services as a part of the cloud computing, definitely it will be a disadvantage for that particular scenario if we do not have a strengthened internet connectivity network. Network connection dependency is also there. Limited features, free of cost, loss of control, latency, vendor lock-in, energy consumption. So these are some of the unpredictable performance and no technical support available. These might be some of the limitations of the cloud computing. So as far as the core computing components of the traditional data centers are concerned, application program employed to carry out numerous computing functions. It may be an operating system, database management systems, and any other application which is there as a part of the cloud. DBMS, it is an administration system which offers the ability to save or get data from the rationally prepared tables. Compute is computing resources, basically computing resources which work numerous applications using various elements. Storage is another thing. This is used to save the data for often use. And the network, as far as the network as a service, it is the ability to communicate among the system. It assists us to share the data and the resources. Now, next comes is the IoT cloud. So this is the main thing of today's discussion. After having said too much about the cloud computing environment, then what we want to have with the collaboration of this IoT with the cloud computing environment. So this cloud computing can be seen as an enabler in respect to the IoT solutions. IoT solutions, whether it is whether we talk about smart homes, smart cities, better healthcare facilities, these are all enabling technologies or enabling areas where exactly we want to uh, integrate both the technologies, cloud computing as well as IoT solutions, to have better services and better delivery of services. IoT is what? IoT is anything, everything connected to the internet to enable different variety of services. So this is IoT. So more or less, anytime, anything kind of where we are having pool of resources which are available to us is called as the cloud computing. So like to see how the amalgamation of cloud technology with the IoT likely to help overall performance of these IoT services and the cloud services. So over here, we have tried to compare the IT cloud and IoT cloud, where on the one hand we are talking about the information technology, and on the other hand we are talking about the Internet of Things cloud. So one size does not fit all. If we say that IT cloud is IoT cloud, this is not true. This is not the true thing. But definitely, we'll have to talk about the tailor-made solution for the newer technologies when we are talking about the IoT cloud. So this is the motivation that wide adoption and deployment of IoT led to the high demand of data storage, processing, and management of services in the cloud-based data centers. So definitely, when we are talking about 50 to 60 billion devices, which according to one of the studies, it says that 50 to 60 billion devices are going to be connected by 2025. So definitely, the demand for the data storage, the demand for the processing capabilities, the demand for management services, as etc., are going to be in high demand. That strong integration needs between the IoT and the cloud services. So this is there. The integration of both the technologies, IoT and cloud, definitely needs to be there in order to provide better, efficient, and better and efficient solutions in terms of services to the users, ultimately services to the end user. So cloud provide excellent elastic computation and data management capabilities for IoT. So thus cloud services now act as a computational and data processing platforms as well as management platforms for the IoT. So I don't want to indulge into the basic definitions of the Internet of Things that everybody nowadays have definitely an idea about that what we are going to uh, talk about in things in Internet of Things, that these things that I mean, it could be anything, have unique identifier and are able to exchange data over the network without requiring human to human, human to computer interactions. So this is more and more connected things. So from this particular diagram, you can think of connecting the different things, be it a fridge, be it a washing machine, be it your television, be it a watch, be it your landline phone, or anything other than that. You are talking about connecting these things over the network. So basic IoT architecture, when we are talking about the basic IoT architecture, definitely we have to talk about the things which are going to be connected over the network. We have to talk about the gateways, and then we have to talk about the network and the cloud. So what these things are, these things actually constitutes of your sensors, actuators, IoT enabled devices, and the mesh networks. And what your gateway constitutes of, your gateway constitutes of your thread, Bluetooth, Zigbee, RGID, NFC. These are all technologies which we are going to connect with the gateways. And then cloud is going to be accessed with the help of cellular technology, Wi-Fi technology, mobile, DSL, or fiber. So these are all network and cloud. So definitely the main building blocks of basic IoT architectures are the things which are going to be connected on the network, then gateway, then the network and the cloud. So I hope that you can easily, with the help of this particular diagram, you have actually visualized the things what is there as a basic IoT architecture. So aspect of IoT is definitely scalability. Scalability is the aspect, or one of the issue is there in the Internet of Things. Big data is another concern. As in today's discussion was the role of the cloud computing in Internet of Things. But definitely when we are going to integrate all these technologies, so big data is also plays a major role in order to what we can say, in order to make the Internet of Things successful. uh, so real-time phenomena, highly distributed heterogeneity, these are all aspects of the IoT. Now, what is the role of the cloud in IoT? Cloud platforms are frequently used in IoT systems. Cloud offers potentially huge amount of resources in terms of the data storage and flexible data analysis. So it has the ability to bring flexible and scalable processing resources for the data analysis purpose. Adaptability of cloud services help to deal with the new requirements, firmware and system updates of IoT system using various processing software. It offers new capabilities over the time. So whether we talk about data storage or the flexibility of data analysis, these are all there as a part of the role of the cloud in cloud computing. So these are just if you just see this particular slide, this particular slide talks about the private cloud, the public cloud, the hybrid cloud, which are the things we have already discussed, and the services which we are going to take from the IoT environments like servers, the cloud, from the cloud environment like servers, storage, mobile application, and databases, etc. As far as features of the cloud computing is concerned, resource pooling, on-demand self-service, easy maintenance, large network access, availability, automatic system, economical, security, pay-as-you-go, and measured services are concerned. So this is, you can say, the previous two slides are just the repetition of what we have seen in case of cloud computing, but definitely the role of cloud in IoT is been clear from the coming slides also, that if we talk about the applications of the cloud computing, so the cloud storage is one thing, server, mobile computing, cloud security, these are all there as an application of the cloud computing. So this is, I don't want to go into the details again, because these are the one and the same thing what we have discussed earlier also regarding the computing, regarding the cloud computing. Now this is a particular scenario of IoT cloud system where A top level view reflect the IoT as a well integrated system with the cloud data centers to establish a uniform infrastructure for the IoT cloud applications. So on this particular diagram, which is IoT cloud platform, on left hand side, we have different IoT cloud applications which are being connected to the cloud platform, which we have named it as IoT cloud over here. And ultimately, on the right hand side, we have different devices which are capturing the analyzed data from the IoT cloud. So integration of these technologies demand coordination between them. Obviously, when we have to integrate both these technologies, cloud computing and Internet of Things, definitely we have to talk about the integration of both the technologies. So standardization of the technologies comes into the picture, as we have started our today's discussion with the definition which is given by National Institute of Standardization and Technologies. So definitely the role of standardization comes over here also. So this means a cloud service can request an IoT service that includes several IoT elements to reduce the amount of sensing data. So in order to, I mean, if more than one devices are getting the same not getting but sensing the same data, so definitely you can use the number of devices which are capturing or which are sensing this particular data, and accordingly these decisions you can take it very easily. So IoT service can request the cloud service to provision more resources for future or upcoming data. So definitely IoT services, any of the IoT services when we are talking about, so this can request the cloud services to provision more resources for the upcoming data. So these are some of the elements which are taken as the cloud standards, IoT cloud standards. So these are the elements of the IoT solutions where we have IT users and end user application as a user layer. Proximity network, we are talking about the physical entity where some devices are being connected in terms of the sensors or the actuators or the agent or firmware network connection, and this is connected to the IoT gateway. So whatever we have seen as the architecture or the elements of the cloud IoT, this is the elaborative version of the same, where we have public network, that is the peer cloud, and provider cloud. All these applications, or these which whether we talk about on the onto the very basic layer, we are talking about the visualization, analytics, process management, and device storage as one of the thing. And on top of that, you are talking about the IoT transformation and connectivity, application logic, then API management, device identity service, device management, device registry. All these things has to be taken into the consideration where we are perceiving of a technology which is basically the amalgamation of both the cloud computing and the IoT. And on the enterprise network, we have enterprise user directory, enterprise data, enterprise application, etc. So this next slides will give you an idea or just the elaborative way of all the things. This is just the cloud reference architecture for the IoT. Where everything is same, but we are giving an idea that how things will actually move from one layer to another layer, where we talk about the layers in terms of the user layer, proximity layer, public network, provider cloud and enterprise network. So these are all connected. So this is the cloud reference architecture for IoT. So this would also be available to you people, as I'll be giving you the reference material for my today's lecture. So this is the detailed component diagram. I mean, in previous diagrams for edge services, for IoT transformation connectivity, for visualization, for analytics. I mean, this is just the detailed component diagram, that what it exactly constitutes of. When we are talking about the enterprise data, when we are talking about the enterprise applications, when we are talking about the visualization, when we are talking about the edge services, what it exactly constitutes of. So I hope you can give some emphasis on the detailed component diagram or the complete picture of IoT cloud, where this is just the integration of both the technologies, IoT and cloud. So next, moving on to the infrastructure protocol and software platforms for establishing an IoT cloud is concerned. These are some of the types: IoT clouds and purpose, which is there for enabling technologies. Now this is a point of discussion which I want to just elaborate, or which I want to discuss with you, is regarding the engineering principles of IoT cloud system. We have some principles like principle 1, principle 2. We have some set of 7 principle which talks about principle 1 says that enable virtualization and composition of IoT component as unit. So likewise, we have different principles which have been defined over here. And ultimately, summary of this principle is in terms of that in case of deployment phase, what are the principles? This plus sign indicates the principle supports and listed perspective listed in and the perspective phase, that in deployment phase, right from your principle 1 to principle 6 are going to be utilized or are going to be used in the development phase. Deployment and provisioning phase, these are some of the principles. Principle 1, principle 3 and principle 4 are going to be utilized. So likewise, for the operation phase, for end-to-end engineering and optimization, development and production symbiosis, and elasticity coherence, these are the principles. This is just the indication that I mean, this is proposed by certain researcher, and definitely he has proposed that these principles are going to be used in the IoT cloud systems. So basically, this will give you an idea. So this is iCommerce, an IoT cloud system, where this is what we can say. iCommerce service and tools, where we have IoT governance, deployment and configuration, monitoring and analytics, elasticity control. So these are all being deployed, configured, and controlled, and this has been integrated with the IoT cloud system, which is there as a software layer basically. So this will give you an idea of IoT cloud system. And example, what we can have, or what we can discuss while discussing the amalgamation or integration of both the technologies, is developing vehicular data cloud services in the IoT environment. So whatever is the vehicular data, developing the vehicular data cloud services in the IoT environment. So these are some of the case studies which are dependent upon the IoT cloud influenced a novel multi-layered vehicular data cloud platform is being presented over here. So this is the part of the IoT, where we have sensors, actuators, GPS devices, smartphone, other internet access devices, and all other things which are the part of the IoT basically. And the communication technologies, what we are taking use of these communication technology is satellite network, wireless network, or internet. And on the middleware, we have on top of that we have cloud computing. I mean, different services, whether we want to take the software as a service, platform as a service, infrastructure as a service. So this is a kind of scenario. This is a very peculiar example, or the scenario what we can think of with the help of this amalgamation of these two technologies, cloud and IoT. So this is I'm just concluding my discussion over here with this particular example. These are all related things, that vacancy detection by the sensors. These are some of the case studies what we can have. Vacancy detection by the sensors in terms of finding the parking space in the parking, basically. So these are some of the examples, and you can also do some research on these particular areas. That what are the different application. For example, nowadays the very hot area is Internet of Medical Things. So how in case of Internet of Medical Things, you are going to basically take advantage of Internet of Things and cloud computing as such, and you can do the case studies for those also. So these are very hot areas, and definitely with the developed technologies like cloud computing, we can integrate, we can have advantage of both the technologies. So as a summary of today's discussion, IoT is a dynamic and definitely an exciting area, covering a wide variety of application. Many IoT systems are going to be introduced in recent upcoming future. Challenges such as scalability, speed, safety, security, privacy need to be addressed properly and on priority basis. And cloud computing offers potential to use large amount of resources in terms of storage, flexible and scalable processing to analyze the data. And IoT Cloud is an enabler to realize the variety of services. So at the end, I'll conclude my discussion with the last point, which is there, as IoT Cloud is an enabler to realize the variety of services. Few of the services, few of the case studies we have discussed in terms of finding the parking space in the parking lot. And I've given you some idea also about the area of IoMT, Internet of Medical Things, where you can actually take the benefit of integrating the cloud computing with IoMT, Internet of Medical Things. So thank you very much. Thanks a lot. Once again, I thank you all the organizers for organizing this training program.
So there's a question on the chat box. Is there any scope of IoT in farming?
Yes, there is a lot more scope of IoT in the farming. Basically, when we usually talk about the sensor networks. I mean, this starts from capturing the data with the help of the sensors, and as you can see the different scenarios, that the first level of the requirement is in terms of the sensors only. So sensors are going to capture the data, and ultimately in the field of agriculture, IoT can play a very vast role.
There's another question: what percentage of use of cloud computing is done in IoT?
I mean, as far as percentage is concerned, this is a burning topic, and ultimately, whether we talk about the big data or whether we talk about the cloud computing, ultimately, all these technologies are the matured enough in order to sustain, or in order to help the upcoming technologies like IoMT, IoHT, or Internet of Things. Basically, this is all basically the Internet of Things. So somebody can name, for example, the last question was asked was regarding the agriculture area. So somebody can later can take the field like Internet of Agricultural Things. So over there, so as far as percentage is concerned, there is nothing like that, but definitely these are the enabling technologies which are going to realize a variety of services in case of IoT cloud environment.
So thank you and good morning to everybody. And my special to RAJIV National Institute of Youth Development and NIT for giving me the chance to deliver my lecture on this certificate course on cloud computing. So today I will discuss about this cloud computing platforms or cloud computing environment for running the traditional monolithic applications as well as how we can leverage those platforms for running the today's modern microservices. The overall topic of discussion is listed here. So today is day 3. So I think already you have some fundamentals or concepts on cloud computing. So I will briefly discuss some fundamentals in cloud computing that are necessary to understand these microservices and run those microservices in the containers or in the kernels. Then I will discuss about the difference between the traditional CAD-based monolithic applications and today's microservices. Then we will discuss about the sweetness of containers especially the Docker containers. So how we can leverage those Docker containers for running microservices. And then we will discuss about the unikernels and how unikernels outperforms sometimes the containers for running those microservices. And if time permits, we can also discuss about various resource scheduling strategies for running both the microservices as well as the virtual resources in the cloud environment. So let's start with briefly about some fundamentals discussions on cloud computing. And I hope all of you who right now know what a cloud is. So this point is to discuss about the definition of the cloud. Simply we can say that in cloud environment, there are two parties involved. One is called the cloud service provider, who has enormous amount of computational resources. So basically the blade servers kind of thing. What it does, these blade servers are arranged as racks, and the racks are placed in some rows. If you look at that, so within that, if you see within this village, so each of the tower is a rack kind of things, and the racks are arranged to form a particular row. And there are some multiple rows up there. So that creates a huge amount of, tremendous amount of computational resources. Previously, they deploy this kind of resources in the form of data centers for running their scientific jobs that needs millions of codes for doing that experiment before the development of the cloud itself. But nowadays, what it does is that they provide those resources on ring, because most of the time those resources are sitting idle when the experiment is not going on. So the people thought that, can we put those idle resources on ring to the others, so that the layman, we call them the cloud service users, that they can very easily connect and run their jobs in that enormous amount of resources. So for the users, they don't have this kind of environment, and for the provider, they have some idle resources. So cloud computing comes to meet that gap, that the users can use those idle resources and just pay a little bit of money for using those tools. So cloud service provider offers those as services, and the cloud service users use them and pay money for using those services. But this is simply a distributed kind of platform. So how the cloud is different from the traditional distributed computing platform? So the features that make it efficient one than the traditional distributed are listed here. The first one is the on-demand self-service. That means that users do not need to have an agreed upon meeting between the provider and the users. Whenever the user needs, they just connect, create an account, and run their job. It's on demand and self-service. There should not be any third party who will make the environment ready for you. So whoever the user itself can use the services themselves. So that means there is a very minimal interaction between the provider as well as the users. The second one is the broad network access. The users can access those platforms using laptop, mobile, smartphone, desktop, or even server. So for any device, if they have a network connectivity, they can access those resources. So we say that it can access from a broad categories of the network. And third important thing is that these are not dedicated for the users. The resources are shared. So the multiple tenants are using the same resources, but they thought that they are dedicatedly using the resources. So the cost of the resources reduced drastically due to that multi-tenancy features. And next is the rapid elasticity, that the users can very quickly increase the resources or decrease the resources. So the scalability is very high and very quick. So that's why rapid elasticity is also involved in cloud environment. And finally, we will have a measure, a way to measure how much resources we need for the services, so that we will pay for only the amount of resources we use. Like any other technology, these features make enrich the cloud environment, but at the same time, it also poses some issues of using those cloud resources. Some main issues are the inherent latency, because here we need to upload our job to a long distance and to get the results back. So there is inherently some latency involved. So if the jobs are interactive, cloud may not be best suited for them. But if the jobs are of that job kind of things, so they can upload once, job will be executed, data to the third party. So we have to rely them that they will not breach our data and the services there. So security also you have to consider and make some burden to our adoption of the cloud environment. And the last one is the vendor locking. That means whenever you was running your jobs inside a cloud service provider, you are using a number of APIs. Now, whenever you want to switch to another service provider, the APIs will not be supported here. So that means you are locked by that provider. So due to that vendor locking also, you may face some problems. But lots of research are going on to get rid of all those issues. And many of them are already handled by the research community. Anyway, with that, you have some basic idea of how the traditional distributed computing environment differs from a cloud computing environment. But ultimately, internally, cloud computing is a emerging versions of the traditional distributed computing platform. Now let me discuss about what is the technology behind providing this kind of cloud services. What we mean? Suppose you have this kind of data center, you are a rich person, you have this kind of data center and huge amount of resources available to you. So what you need some extra things to provide those resources as a cloud to the user. So main technology that you need is a virtualization. So we need a virtualization software. This is simply a small software called hypervisor or sometimes called virtual machine monitor. What this software does, this software basically creates virtual machines. What is the virtual machine? Virtual machine basically creates a virtualized version of the hardware. So this is a virtual CPU. Similarly, you can create a virtual LAN card. Similarly, you can create a virtual RAM. So those virtual hardware can be assembled to form a virtual machine. And on top of that virtual machine, you can install any operating system we call them a guest operating system, which may be different from the corresponding host operating system. And within the same machine, you can create any number of virtual machines. For example, here we create 2 virtual machines. Now, the advantage of the virtual machine is that they are running in isolation. That means the jobs running in one virtual machine cannot access the job or resources of other virtual machines. So that also provides some kind of security to you. And based on your requirement, you can decide your virtual resources. These are the major services you can implement. How much CPU you need, how much RAM you need, you can decide. But they will ultimately be mapped to the available physical resources of the blade server. So those blade servers are coming from these racks they provide. So if you have any question, you can ask in between also as well. Or at the end, we can discuss question. So now, there are 2 types of hypervisors available in the market. First one is called type 1 or bare metal, and the second one is type 2 or hosted. The difference is that in type 1, there is no host operating system. The hypervisor sits directly on top of the bare metal or the hardware. So hypervisor itself acts as an operating system. That allows you to run the virtual machine. Compared to that, in type 2, which is called hosted, here the hypervisor is running like any other process on top of the OS. And they creates the virtual machine. So based on your requirement, you can choose any of them. The examples I have already mentioned that Zane, VMware, Heuristics. So these are the examples of the type 1, and VMware workstations or KVM. They deploy the type 1 and some others they use type 2. Both have some pros and cons. In this kind of environment, there is a problem. First, you need to understand how they are. Since they are gateways, look at these virtual machines. Whenever this application gives a system called ways, the operating system, these are just a traditional operating system. This is not a special one. What the operating system does, they directly execute on the hardware. So whenever they execute on the hardware, ultimately this fault goes to direct execution on the hardware because the gateways are running in the privilege mode. Similarly, whenever this application gives a system call to that gateways, these gateways also directly execute on the hardware. Now, generally the operating system solves the race condition among the multiple applications. But the same thing occurs here. Because there are multiple ways they are accessing some non-shareable resource at the same time. So, who will resolve this race among the gateways? This is the main issue we need to solve to understand how virtualization works. So, let us see some probable solution to this problem. The first simple solution is that to leverage the concept of the rings. The rings are the security of the privilege levels. So ring 0 has the highest privilege and the ring 2 and ring 3 and the ring 3 has the least privilege level. So generally we told that the ring 0 is always running in ring 0 in the privilege mode and the ring 3 our codes are running at the user mode. But apart from these two rings, there is also two other rings in the x86 architecture called ring 1 and ring 2. Now, what the solution provides? Solution says that whenever you install that hypervisor software, this is running under the ring 0, the highest privilege level. And whenever you install some gateways on the virtual machine, so they are mapped to the, or they are running under ring 1. So obviously, whenever the application gives a system call, the OS gateway try to execute based on the hardware. What the hardware does? The hardware looks at the ring 0 instructions are coming from ring 1. So lower level privilege. So hardware will not execute it, rather they will give a trap to ring 0. And in the ring 0, the hypervisor are listening for those traps. So all the gateways, whenever they try to access the resource at the same time, they will be trapped by the hypervisor. There is a single hypervisor, so they will resolve that issue and execute safely one by one within the available hardware. So this is a very simple solution to solve the race condition among the gateways provided by virtualization software. But this simple solution will not work for most of the processors because in many processors like Intel x86 processor, it is Intel x86 microprocessor, there is an instruction called pop-it. And this pop-it instruction is executed during the context switch between two processors. Now what did that? The design of the x86 is such that whenever it looks at a pop-it, this pop-it instruction belongs to ring 0. So whenever hardware sees that the pop-it instruction is executed from some higher level rings, the hardware simply drops that instruction. It does not send any trap. So if the instruction is not trapped, the pop-it instruction is not executed. If the pop-it instruction is not executed, the guest OS cannot perform the context switch. So most of the x86 Intel processors, they cannot perform the context switch within the guest operating system. So this simple solution will not work for most of the Intel processors. For that reason, they provide two solutions. The first solution is called the full virtualization technology, and the second one is para-virtualization technology. So let us see what are these two technologies. First, the first one, in case of full virtualization, you see, what is that? The hypervisor monitors the execution of the instruction and search for those instructions when such an instruction is executed. Once the hypervisor observes this kind of non-virtual instruction executed, they dynamically perform the translation called binary translation. Actually, it is trapped and the hypervisor do some jobs on behalf of that. So even though they are not trapped, the hypervisor accept this, they will be a trap and resolve it. Even though hardware dropped that instruction, hypervisor executes it safely. So this is called the binary translation. But due to this active scanning and this binary translation, the whole system is slow. So that's why many people are not using the full virtualization. Rather, for example, Amazon AWS, they are deploying this para-virtualization, or specifically in the GEM technology, they are using para-virtualization. What the para-virtualization does? In case of para-virtualization, what they did, they modified the guest operating system. First thing. Second thing is that instead of putting the guest operating system in the ring 1, the guest operating system is also mapped to the ring 0 along with the hypervisor at the same privilege level. And what they modify the kernel of the guest operating system? Whenever there is a system called the guest operating system, they change every system call by a corresponding hypercall. Hypercall means the call to the hypervisor. So previously it was system call to the operating system. Now the system call is followed by a hypercall, the call to the hypervisor. So ultimately, whether this is a trap or not, they will ultimately go to the hypervisor. And this hypervisor also does not put so much overhead because they are running both in the same privilege level. So for this hypercall, you do not need any context switch. So since there is no context switch for the hypercall, so they do not put so much overhead. The same overhead because previously it was trapped, right now there is a hypercall. So overhead-wise, this is not much. Whether the hardware does not need to filter for the trap and listen for the trap. So hypervisor sometimes provide the better solution than the previous one and can execute them safely. So most of the solutions we are doing today are following that paravirtualization. But the problem with the paravirtualization is that you need to modify the kernel of the base operating system, which sometimes is not allowed for proprietary OS like Windows. So that's why Microsoft comes with a modified Windows version itself for cloud environment, and they provide different image for the cloud and different image for the traditional user. So with that, I hope you have understand how in the cloud environment the various jobs are executed within the shared environment and how the virtual CPUs work. In the same way, the virtual LAN card, virtual memory, and all those things works. So I just covered how a virtual CPU works, and since already we have some discussions on the cloud, I am not discussing about how the other resources can be virtualized. Rather, let me discuss about the various services provided in cloud environment. Now, as long as you are just using those virtual resources, that means you request to the cloud service provider, they use their hypervisor to create a virtual machine for you. As long as they provide a set of virtual machine to you, you are accessing this as an infrastructure as a service. Now, once you get to infrastructure, that is a virtual machine, you need to install the various services. You need to install or configure various platforms and the middleware. Sometimes the users do not need to take this headache for their software development. They want to take those things as a services. But along with the virtual machines, those platforms, middleware, or the services are pre-installed, and they will be provided as a services. Now, in that case, we call it's a platform as a service. And sometimes the users are not interested to develop their own applications. Along with the infrastructure and the platforms, they want the ready-made applications developed for them. The users will just configure the application and use it. In that case, we call it a software as a service. So within that blade server, either you can provide the virtual machine in the form of infrastructure as a service, or you can have a pre-installed platforms and provide a platform as a service, or you can have a pre-developed applications and you can provide as a software as a service. So the users can access the services at either infrastructure level or platform level or services level. And whether this is a software, platform, or infrastructure, internally this is executed like the one I discussed in the previous slide. Now, let me discuss about a concept called virtual machine migration, which is an important concept that you need to implement if you want to implement your own data centers at a cloud environment. So let us look at this. Suppose in your data center, you have two blade servers. In the first blade server, in the second blade server. And in both the blade server, one virtual machine is running that runs some jobs. One virtual machines are running here. Now, you can observe that this is an unbalanced deployment. Because if I can migrate this one of the virtual machines to the others, I can terminate the I can stop or suspend the second virtual machine to save some energy. Hello? Hello, is there any question?
Sir, you can continue, sir.
Okay. So we can perform this kind of migration especially for this kind of energy efficiency, because I do not need to run the second blade server that consumes some energy. And not only the energy, we will need to migrate the virtual machine for balancing the loads. So there can be an unbalanced distribution of the virtual machine to the available physical server. So we can migrate some of the virtual machines so that the load will be balanced among the available physical servers. Sometimes we need to maintain for maintenance. So we can migrate all the virtual machines to another servers for the maintenance purpose, and once it is up, we can again migrate that. Or sometimes there is a host failure and the host recover. After the recovery from the failure, we may need to migrate some of the virtual machines to the recovered host system. So this migration is an important task which we need to implement. I will discuss that how the virtual machines can be migrated in different scenarios. So let us look at various migration technologies. So ultimately there are three different types of migrations. The first one is called the cold migration, warm migration, and live migration. So in case of cold cold migration, what we done, we just shut down the virtual machine in host 1. Suppose we want to migrate from host 1 to host 2. The technique is very simple. Shut down the VM on the host 1 and we start a new VM on host 2. The problem of cold migration is that all the previous running jobs are gone. You have to start the afresh and again all the jobs have to be restarted. But this is a very simple to implement. In case of one migration, what it does, instead of shutting down, we suspend the VM on host 1. And then we copy all the states of the VM 1 to host 2. And we can resume on host 2. So this will continue the jobs where it is suspended. So all the previous states are saved and we can continue. But the downtime is high due to the suspension for the long duration of the copy. So that is sometimes reduced by live migration. What does in the live migration? In the live migration, while we are copying the VM state to host 2, then the VM still continue to run. So the downtime reduced drastically. So the live migration has lots of interest among the researchers and the community who are using the cloud platform. Now I will discuss how we can implement these live migrations in cloud platform here. Let us look at how we can implement the live migration part. So for this, let us take an example. Suppose there is a host 1. Within that host 1, one virtual machine is running and we want to migrate it to host 2. The first thing we should know that the backend stable storage are not directly attached to the virtual machines in cloud environment. Rather, they have large shared storage like a storage area network. So these storage area network blocks are mapped to the corresponding VM. So for migration, you do not need to migrate those blocks to that. We just need to change the mapping or the mount points to the host 2. But we need to copy the in-memory because the RAM card or the memory pages are in the host 1. So those memory pages has to be copied to host 2. So what we done for that, first we need to create a virtual machine in host 2 and then we have to copy the memory pages one by one to the host 2, all the memory pages. As long as the remaining memory page goes to a certain value that go below the threshold. When the remaining memory page is very low, we pause the virtual machine at host 1, we pause it and move the storage connectivity. The storage connectivity has to be moved to the host 2 and we have to start the virtual machine and terminate on the host 1 so that the VM is migrated. So main issue is that how can we copy the memory page while the VM is running? This is the main challenge of live VM migration. For that, there are two approaches. The first one is called the pre-copy approach and the second one is called the post-copy approach. In case of pre-copy approach, what it happens? So once you decide to migrate, what we do, we mark all the memory page in the source as the data page. And we start transferring the data page. But while we are copying the data page, the execution is still continuous in host 1. So if a data page is copied, it is marked as undati. And if the execution again writes to the same page, it again becomes a dati. So the same page can become a dati and undati multiple times. But as time goes, as you are copying that, it becomes undati. As it again reading, it becomes undati. So gradually, the number of dati pages will be reduced. Once the number of data pages is goes below some threshold, we suspend here. So if we suspend, no new data page will be created. Only we will copy those remaining data page and we transfer the CPU states there and we can start executing on the second host. So since we are copying, before we start the execution at the destination, this is called pre-copy approach. Contrast to that, there is a post-copy. In the post-copy, what it does, immediately suspend the execution on the host 1. It only copy the CPU state because the CPU state are small. Only the process control blocks are there, we need to copy it. We don't need to copy the memory page. And we can, after copying the CPU state, we can start executing on the destination. Now, while they will execute and we try to access the memory page, so there will be page fault. But each time there is a page fault, it will pull the page, missing page from the host 1 from the backend. And gradually all the pages will be moved to the host 2 and it will continue. Using this approach, we copy fast, or we copy after the execution starts on the destination, we call it a post-copy upload. So by these two ways, only the downtime is very small. That to copy basically takes, not the full memory page as one migration. So that's why most of the companies are following both the pre-copy and post-copy upload based on the situation, whether the copy state is larger or the data page is larger. With that, let me now discuss about the second part. So with that, I cover the basics of a cloud environment, how a cloud service provider can provide a virtual machines, and how the virtual machine technically works inside the blade servers. And I show you how the cloud service provider perform the line migration of the virtual machines for their energy consumption, for reduce the total energy consumption, for their load balancing, for their maintenance, for their recovery from the failure, for all those things. Now let me discuss about my second topic, where I want to discuss about the difference between monolithic applications and microservices. In case of monolithic application, as you see, it's a traditional three-tiered architecture that is used in the older days. For example, we can have a database tier, we can have a business logic tier, we can have a presentation tier, or we can have a vertical security layer. The security layer can be for both database applications and the presentation part. So in this kind of monolithic application development, we basically develop this as a modules. So there can have some database modules, some business modules, some presentation modules, and those modules will interact with each other, and they will interact with the security module as well. But the problem with this kind of monolithic application is that when the applications want to communicate with the other application, it creates a very complex interaction among the multiple applications. One application can be a database, similarly other application can be something else. So whenever they want to interact with multiple applications, a complex cluster-based environment, the overall interaction is very, very complex. And that creates a problem in agile development. So what we did, we moved to web services instead of this kind of modular development. So that every module can be developed as a web services. And they can have a well-defined web service interfaces. So with the development of web service, with the development of these web services, the interaction reduced drastically from that complex application to application interaction to the interaction among the multiple services. Actually, we start to develop our service-oriented architecture or SOA platforms. So in service-oriented architecture, so there is an enterprise service bus. So those services becomes much more reusable and much more known to the others, so that the redundant services are reduced drastically, and they can communicate by a very simplified enterprise service bus to get reduce of the complex interaction among the multiple services. So the services will deploy to the enterprise service bus, and others can use those things. So in general, service-oriented architectures providing a very good environment for writing reusable and dependent codes. Now, with that microservices, today's app-based environment, today basically everything becomes an app that has to be run inside a very small embedded devices, like a smartphone or very low-end smartphone as well. So what they did, so they try to create, so this microservices find a workflow among those small services, and they can use the service-oriented architectures to deploy those microservices. Now, I will discuss that when we move from can be good, how we can use the cloud environment for these applications, how we can use the cloud company platforms for running those kinds of microservices using service-oriented architecture. So the first thing is that whenever we are thinking about the monolithic application, we have different virtual machines. We can have one virtual machine to run the database application. We can have a cluster of virtual machines to run the business layer, and we can have some virtual machines to run the presentation layer. Similarly, we can have some virtual machines to run the security solutions in a reusable fashion, and they can have a large cluster of VMs to deploy your monolithic applications. Now the question is, should we also deploy those microservices, the services in each VM? Now the question is, should we have one VM to one service, like the monolithic application or not? That one we will discuss in our next topic. So now we discuss about the container first. Then I will discuss how the microservices will be mapped to the virtual machine. To understand the difference between a container and virtual machines, you can use these two pictures. Suppose this is a duplex. So in a local area, there are a number of duplex provided by a construction company, and they give those duplex on rent to you. So you can think this kind of duplex as your virtual machines environment. But in that case, you have much more control on the services you are using. But here you do not have much more control because you are using most of the common services like water, electricity kind of things. You are using sharing with that. So you do not have much more control, but the cost is very less. So this is a non-technical description of a container versus VM. Technically, if you see, already we discussed how technically a virtual machine works. We told that we have some blade server. On the blade server, we install some software called hypervisor. On top of the hypervisor, we run some virtual machine. Each virtual machine has their gateways, their application binary, and the applications running. So this is the traditional virtual machine environment. Compared to that, in container, if you see, on top of the host operating system, you don't need any hypervisor. They need a container engine. And the Docker is the most popular container service provider. So Docker becomes a de facto standard for container today. So you should need to install a Docker engine. The Docker engine allows you to create and place the containers. If you look at the containers, container binds the required dependent libraries or binaries along with the app. But it does not bind the OS like the virtual machine. It shares all the containers share the kernels of the host operating systems where they run. But the mapping or all the dependencies are easily resolved to within that libraries or binaries there, so that a container can easily be moved across heterogeneous platform. So if you see the second scenario, in the second scenario, you can see that not only the Docker can be done inside the physical server, a Docker you can place inside a virtual machine. In this example, if you see, on top of the hypervisor, you install a virtual machine. On top of the virtual, because the virtual machine also have a gateways. On top of the gateways, you can install the Docker engine, which can allow you to place the container. So you can place the container inside the VM as well, along with placing the container directly on the blade server. So containers are very flexible to install. Now, for running those microservices, instead of directly mapping them to the virtual machines, we can map them to the containers. Each of the microservices can be mapped to a different container. And these containers, a number of services can be put inside one virtual machine. Since the container are also running in isolations, two services will not interfere with each other in terms of the security breach kind of thing. So with containers, the microservices have become much more versatile to deploy. You have much more control over the deployment of the microservices. So the general practice that we are using today is that each of the microservices can be mapped to the containers, and multiple containers can be mapped to virtual machines, and the virtual machine can be placed inside some blade servers of a cloud service provider, so that you can easily run it. And not only that, the migration of microservices are very easy across the heterogeneous platform. If you look at this is a VMware-based cloud platform, and if you have a target Hyper-V-based cloud platform, these virtual machines you may not migrate to this Hyper-V. But even with the container, even though this is a heterogeneous cloud platform from VMware Cloud to Hyper-V Cloud, the container can easily be ported, and this heterogeneity can be resolved by the Docker engine or any container engine. So if you have a container-based deployment for the microservices, you have a much better control on the load balancing and all other aspects as we discussed during the migration of the game. So this part is for the container case. Now let me discuss about the unikernels part. What is a unikernel? So unikernel are basically specialized single address space machine image constructed by library operating system. To understand this term, let me give you one example here. So already we discussed that in case of container, one microservices is not mapped to one virtual machine. One microservices are mapped to one container, and multiple containers mapped to one virtual machine. That was the concept in container. But in unikernel, again reverse back. One VM for one service with unikernel. So it's not that, that means if you have a microservice and you want to deploy it in a unikernel, each microservice will be deployed to one unikernel and this unikernel will be back to one VM. It's not a mini unikernel to one VM. So how it makes possible? Let us look at this picture. So let us consider this kind of unikernel applications to be running. NGINX one, for example, let us take some service. So if I want to run this NGINX service, like NGINX is one such microservices. Now, NGINX service use different layered services. If you use some third-party application, if you use some library, if you use some operating system services, if you use some kernel module. Now, if you look at this NGINX service, it does not use all the services of the player. It mainly uses dash and Memcache and some other services of the third-party application. It uses only libSSL and libCO and some other service libraries from the next layer, among hundreds of libraries. Similarly, it only uses SSH and init from the web services. It does not use any other services provided by the web. Similarly, for the kernel, it uses HT4, NetFront, DLKFront, or some other services from the modules from the kernel. It does not use many of them. Now, what the concept of unikernel is that can we create a specialized computer that contains all the modules. It contains kernel, it contains service, it contains library, it contains third-party application, but you do only the modules that needs. Remove all other modules that is not needed. And this computer will dedicatedly run only NGINX. It is not allowed to run any other application. So now you can see it's a very small computer and that can be run anywhere, which has its own operating system, kernel, which has its own web services, which has its own dependent libraries and everything. And since the application, there's a single application running, the application can be run in privilege mode because there is no question of the rest condition. So we do not need any context switch. Such a deployment is called a unikernel environment. So this can be done inside of it. So we do not need to run it because it itself has its own environment. Now, if you look at the advantage of this kind of environment, first thing, since we are removing most of the modules, it becomes a kilobyte in size, including the operating system. The whole computer image, including the OS and the services, it becomes some kilobyte in size. So the very first boot, within a fraction of seconds, it's booted compared to the booting time of virtual machine. Second thing is that since there is a single application running, we are running that application, this application in a privilege mode. So we do not need any context switch. And you know that for context switch, lots of overhead over there. So the applications run very fast. So booting time is very fast, application runs very fast. And this kind of things, this is a full-fledged computer. It can run on the hypervisor like a VM. It can run inside a container as previous, or it can run on the bare metal. So you have a diverse options to run those unikernels. And since you remove most of the services from different layers, the attack surface is very small. Because most of the time, the hackers use some unused services and they try to hack your applications. But since you are removing most of the unused services, for the hackers, the attack surface becomes very less. So they need to attack using only those modules that you also use as your service. So for those reasons, this unikernel becomes a very popular choice for putting the applications on cloud environment. So with that, I covered this second part, and before I start discuss about the next topic, I want to take some questions if you have. I will share the question answer, and then I will discuss about the third topic of the resource scheduling part. So in general, we can see the difference between a virtual machine, container, and unikernel. In general, in a virtual machine, we have our hardware, like a web server, that needs a software called hypervisor. That logs some virtual machines. It has its own OS and kernels, and on top of that, the users can run their own applications. can be platforms or software, whatever it is. In case of containers, we see that the OS and kernels are there on top of the hardware as a container platform. But within the container, they don't have the OS or the kernels part. It's not there. Only the libraries and applications are within the container. Compared to that, in unikernels, the kernel, only the minimal kernel that is needed, are put along with the application. And that can be run inside a VM, in the kernel file. So since your kernel is also there along with you, that is your job or applications, it's carrying the OS kernel with you, it can run anywhere. So it can run on top of a smartphone, it can run on top of a hypervisor, it can run anywhere. Since the kernel you are carrying along with your code. So now let me discuss about some resource scheduling problem in cloud environment. So those resources can be a container, it can be a unikernel module, it can be a virtual machine. So I will, for simplicity, I will use the VM to show how the VM can be placed within the available physical machine. But instead of VM, the discussion is equally acceptable for container or unikernel module as well. Now, to understand that how the cloud service provider plays those VMs, because they have some physical machines, we call it a VM, and they have a request of some virtual machines. Lots of virtual machines are requested from the user, and they have a set of available physical machines. So those virtual machines need to be launched inside some blade server or the physical machines they have. So what they done, how to take the decision to place those virtual machines. We call this problem as a VM placement problem. Now, the two important parameters in deciding the placement is how much CPU we have, how much RAM we have. That can have other parameters as well. But these two are the most important parameters. Whenever we launch a virtual machine, there also we need to specify how much CPU and how much RAM. These are the two most important parameters we need to specify for most of the virtual machine requests. And for some other specialized, we need to provide the bandwidth requirement, the disk requirement, or something else. So we can consider each of the physical machine as a large rectangle kind of thing. If we consider the normalized CPU as the length and normalized RAM size as the width, so we can consider each available resources, available physical machine as a large rectangle. Similarly, each user requests some virtual machine, they also request some virtual CPU and virtual RAM. Based on their, after normalization, this can be represented as a small rectangle. Now, our problem is that having a large rectangle, how optimally we can pack those virtual machines to there. So this can be easily solved by a two-dimensional 0-1 knapsack problem. But we have multiple such physical machines. So we have more than one physical machine available. So knapsack problem we cannot use. So for that, we need to use two-dimensional 0-1 beam packing problem. And if we consider along with CPU, RAM, the hard disk, or the available bandwidth, then it becomes multi-dimensional 0-1 beam packing problem. And we all know that a multi-dimensional 0-1 beam packing problem is NP hard. So we need some heuristics to find that solution. So most of the research community and the cloud service providers are basically using some heuristics to solve this multi-dimensional beam packing problem and accordingly to place those virtual machines within the available physical machine base. So optimal solution will be provided by this kind of linear programming problem. I'm not going to discuss about those in details, but if you solve this, it will provide you the optimal placement for that. But this is NP hard that I told you. So for that, most of the users are using, most of the cloud service providers, we are using some heuristics. These are some of the popular heuristics that is provided by CFO in 2015. So they basically use some resource-based fast feed algorithm, best feed algorithm, and overspeed algorithm. So as we use for the OS resource management, those resource management are just slightly modified and they deploy it for finding heuristics which provide some closed solution to that optimal one. So we have also provided one solution in 2017 called the aspect ratio based fit algorithm. So considering the aspect ratio of those rectangles and the aspect ratio of this, so we can find the best fit algorithm. So we have shown that this provides a very close result this INT or the optimal solution. That can also be used for providing this. And today also, the people are considering these energy modules and other part as well, is considering how much energy, not only the wastage, but what will be the total energy to be consumed. So for that, they use the various energy models as well. So most of the popular energy model used in the market is the utilization base. You can place a virtual machine, but that may not run lots of jobs. If it is not running lots of jobs, it will not consume energy. So there is a popular model that how much power will be consumed for that utilization. So based on the utilization, for each physical machine, we can compute that PU, providing that Pmax. So this Pmax can be the parameter of each physical machine provided by the blade server. So using that, you can have this kind of linear model to estimate how much power will be consumed by a particular utilization. And to find how much energy consumed with the duration from T0 to T1, just integrate all the utilization because the utilization is not fixed. So you can measure the utilization by using some monitoring tools, how much utilization at time T. So now that utilization is a function of time, and this PU also is now a function of PUT. Now, if you perform the integration from T0 to T1 of that PUT, you can estimate how much energy you have. So based on that energy also, someone to some contradictory optimization. Someone try to optimize based on their resource utilization. Someone wants to optimize based on their energy. So it becomes a domain of multi-objective optimization problem. So today, lot of solution also provided considering both the energy as well as the resource wastage as a multiple objective and provide some traditional multi-objective solution. Using the machine learning and genetic algorithm also, we have some papers where we provide some closed solution to the optimal one. Now let me discuss about general architecture for scheduling the resources. So already I told you that there is a set of cloud service provider. So each cloud service provider provides some service stacks, either in terms of infrastructure service or platform service or software service. Now there is some cloud user. So the cloud user, it may be very tedious job to decide which cloud service provider will give us the best solution for deploying our application. So for that, there is some middleware. So the middleware will work on behalf of the user to find the best cloud service provider, best services, and deploy them using the services. So now they are called the resource broker. This resource broker sometimes are provided by the service provider itself, or sometimes it is provided by a third party. But general structure of most of the cloud resource brokers have these 5 modules. One is called application repository, second one is the policy and quality of service, and third one is monitor. And the other 2 are deployer and the controller. So what the user does, user for deploying his application into the application repository, that application he needs to run inside the cloud and using a minimal cost. And for using the cloud services, they can decide their own policy and the quality of service requirement or arbitration degree. And also they can have the dedicated monitoring. I want to monitor that specific features of my job running here. So these 3 will be provided by that cloud service user using some unified API. Now, once the application is deployed by the cloud service user, what the deploy module does, they take the application, take the policy and QoS requirement, and take all the available cloud service provider in the market, and that can do some optimization, that can run some optimization algorithms there. Lots of research is also going on in that deploy module, how to find the optimal resource requirement for this application to meet this policy and the quality of service. And based on that decision taken by the deployer, what they does, they launch some virtual machines and place those virtual machines in the decided cloud service provider using their service tags. So these VMs can run some platform, these VMs can run some infrastructure, these VMs can run some software. And also these VMs can run in different cloud service provider as well. After they deploy it and for their applications, they take the monitoring context provided by this cloud service user. And accordingly, they install some monitoring agents within the each VM or some cluster monitoring tools. What this monitoring agent and the cluster monitoring tool does, they monitor the CPU utilizations, energy, and various parameters they have, and they will send an alert message to the monitor. Now the monitor will coordinate those alert messages, and if any abnormality found in the resource health of those environment where the jobs are running, the monitor will send some events maybe some abnormal events or normal events kind of things, through some API to the controller. Once the controller receives the events, so they will take the policy and QoS requirements. From the policy and QoS requirement also they can send some events, or the VM can also directly send some events to the controller. Once the controller receives some events, they will analyze the application, policy QoS requirements, and what happened to that from the monitor. It can again perform some dynamic analysis on that current state and can fine-tune the resource requirement of that. So this kind of environment can be used for your auto-scaling kind of environment. So let me give simple example how this kind of broker-based architecture can auto-scale your resource requirement. Suppose this is the cloud infrastructure and these are the resources, and as per time your demand for resources are increased and decreased like that. So how do you know? Because you deploy and your middleware or the broker basically monitor all those things. So once they monitor that demands, the nodes, that will send the scale of events. That the demands increase, you need to add some extra node. So once the demand increase, the resource requirement increase, so the monitor will send the events to the controller will launch some extra node. So your resource increase. After that point, the monitor will observe that the demand decrease. So the monitor will send the events to scale down to the controller. The controller will release some of the virtual machine and your resource gradually decrease there. So based on whenever your new virtual machine requires and whenever the extra virtual machines will be dropped, will be paid by the monitoring, and the controller will actually launch some extra virtual machines or terminate some virtual machines to build your capacity and to reduce the total cost. So that way you can do. And not only that, sometimes you may forget about this part. Sometimes you may need to predict it, that what may be the future demands. So instead of exactly monitoring what happened to that, if we can predict what may be the future demands, so we can businessly add some virtual machines so that the quality of service will not be affected so much. So for that, what is that? Many of them are using the Markov chain-based predictions because that provides much better prediction in case of resource utilization part. So what did that? They basically the measured resource utilization mapped to some states, and based on that, the Markov chain have a history of state transitions. For example, the initial state can be S1 to S2 to S2 like that. Now from that, it can generate a transition matrix for that based on that probability. So these are the probability. What is the probability of transition from the state 1 to state 1? So that way we can have the Markov chain matrix from the history of the states, and after that we can use this Markov chain to find what is the transition probability for the future. And based on that that Markov chain, we can predict what should be the next case. For example, for this case, we can predict that the next one will be S1, and after that the next state will be S2. So based on that, if a particular state is above some threshold, we define some thresholds there. So if it's above some threshold, we can scale up or scale down based on the predicted load there. So that way also we can manage those resources. So with that, I can complete my discussion. So if you have, I can discuss some questions. Any questions there? That within the next half an hour, I can give you some demonstrations of AWS, how you can use it in the real platform.